You need to know the flow of current. They're telling you there is the flow of current. They're actually tracking it. Remember, current is from positive to negative. So you start there. At that point, current is going to split. We call that one, it will go to I2. I think this is I2. And then some of the current will go to I, because it's going through resistor 1. Let's call it I1. So we have got current there, I1. So when the current split, it automatically tells you that these two are in parallel. So we are going to do a parallel formula there. Then the current comes in, then it combines there. See, it will combine. So I1 and I2 will combine back to IT. But when it comes here again, it do a three thing. That is I3. Let's call that I3. So we'll call this I3. We'll call this I4 split, and then we'll call this I5. So whenever there are different currents, again, these I0 are in parallel. So let's do this quickly and try to find the answer there. Hello again, our most valued student. My name is Confident and welcome to the last topic. I want it to be last topic on industrial electronics, a surprise topic, a surprise subject, and it's on calculations. That is electric circuits, resistance, current, power, voltage. That's what I'm going through here. But as I said, I'm not an expert of industrial electronics, so that's a disclaimer. But I find the topic of electric circuits very common to the one in engineering science. So how did I come about it? There is this student who was going through some of our videos under electricity on engineering science, and by the name Tandega. So these are students' comments, and this student is like, I love the way you explain. Can you please do the electric circuit of industrial electronics? They are more complicated. N2, please. So that please kind of melted my heart. I was like, okay, Tandega, let's get it going. So that please helps. So what am I trying to say, guys? It is important for you to subscribe. It is important for you to be active. Don't be passive. Be active on this channel. Comments, leave your comments, engage with the channel. It's there for you. It has you in mind. I always keep on saying this is 24 minutes with you in mind. So if you are benefiting from this channel, subscribe right now and ensure that notification bell is turned on. It explains, it helps to know that there are people benefiting at the end. Now look at this. We're doing the last part, but this one I'm just gonna go a little bit faster. The other one was around 40 minutes. This one was around, the last one was around 28 minutes. This one will be around short minutes, just to get it done faster so that you can see how you go about this. So when was this paper? This is what? April 2021. And then look at this. It also says study the circuit diagram in figure 1 below and answer the questions. There is the circuit diagram. So they gave us two, I think this is R1, R2, this must be 2 ohms, okay? R3 is 40, 20, 40. And then we've got total voltage of 132. That's that. So what's the question saying? Let's look at the questions here. Out of 18 marks, calculate the following: the total resistance in the circuit, 6 marks. The total current in the circuit, 2. The current passing through R2, R4, and R5, 10 marks. Wonderful. This is, to me, sweet. This is sweet. Look at this. Total resistance. That's the first part. I'm going to do this fast now. You need to know the flow of current. They're telling you there is the flow of current. They're actually tracking it. Remember, current is from positive to negative. So you start there. At that point, current is going to split. We call that one, it will go to I2. I think this is I2. And then some of the current will go to I, because it's going through resistor 1. Let's call it I1. So we have got current there, I1. So when the current split, it automatically tells you that these two are in parallel. So we are going to do a parallel formula there. Then the current comes in, then it combines there. See, it will combine. So I1 and I2 will combine back to IT. But when it comes here again, it do a three thing. That is I3. Let's call that I3. So we'll call this I3. We'll call this I4 split, and then we'll call this I5. So whenever there are different currents, again, these I0 are in parallel. So let's do this quickly and try to find the answer there. So the first one is, just to work on this one, divide in two. The first one is 1 over R parallel. The first parallel is 1 over 2 plus 1 over 2. So what is R parallel 1? Is equal to 1 over, remember, 1 over 2 plus 1 over 2. So therefore, RP1 is equal to, so 1 over 2 plus 1 over 2. So it can give us the answer there. So let's see what it gives us in here. So it's 1 over 2. Remember, I'm looking at the total resistance, plus 1 over 2. It will give me the final answer. It's 1. Actually, it's 1. So this is 1 ohm. So this is 1 ohm. Next one, we do the same thing, but the only thing with this one is, I'm just going to do it fast. R parallel 2. I'm now looking at this guy here. Is equal to 1 over, which is 1 over 40 plus 1 over 20 plus 1 over 40. So it will just give me the answer straight away. You're allowed to do that. Then when you do that, it's 1 over, as I'm saying, I'm now doing this a little bit faster, 1 over 40, because that's what you need to be doing, like in your exams. You don't have to be taking it so slowly. That one was just for you to understand. So 1 over 20 plus 1 over 40. When you do that, it gives you the answer straight away. You say 1 over, then 1 over 20, 1 over 40. It will give you the answer straight away. It's 10. So this thing is 10 ohms. So guess what? I've got that one, which is 1 ohm, this one, which is 10 ohms. Do you see now the shape of this? And now I'm going to have to draw it in the other side so that you can see how it looks like, because I'm going to be working on the other side. So that diagram is like this now. At the bottom, they had the positive and the smaller negative. It was like that. And then, let's look at it. It had that total there, which I now have. I have this total here, and I'm going to use a different part to indicate that this was not the original. It's 1 ohm, this one. Then it continued. I got another total of this one. It was 10. See? So again, sorry about this. So I'm gonna use a different one to say this one was also 10. Okay, that's it. Then you do this, you do that, and this will combine. I don't think there was any other resistor. That's it. And then this was 32 volts. So here, remember I said plus minus, so it's 132 volts. This is what? 10 ohms. This is 1 ohm. Are you with me? Now, look at the flow of current now. From positive to negative, okay? There is the current, which is IT. There is the current. It is the same current IT coming in here. Now, IT goes through 1. IT comes out of 1. The total current, it goes through 10. And IT comes out of 10. When it's like that, it means these resistors are in series. So R total, which is R series, is equal to, you can state the formula, R 1 ohm plus R 10 ohm. You can just write the formula, or just say 1 plus 10, which is RT. They're in series, guys. It's 11 ohms. So there is the answer. 6 marks. Calculate the total resistance in the circuit. Right. The total current in the circuit, 2 marks. Now, how do you find the total current in the circuit? As I say, it is important for you to use this formula here. In the previous lessons, I think I did 2 lessons back, I explained the formulas that I prefer. But for this one, voltage, VIR. It's a very important one. There's the other power formulas. Now, this V is equal to IR is a very, very, very important one. So what I do, I use it here to say V is equal to I dot R. And then from that, I come up with a triangle, so that it can help me find whether I'm looking for resistance or current. So VIR. So the question says here, I'm supposed to find the total current. Remember, it's total current, that IT. So what do? I, there is the I is equal to V, there is the division line over, you see that, R. So what is my IT is equal to V, the voltage. They gave us 132, there is the voltage. They say it VT, this was VT, if you remember the question. Let's go back, you see, they gave us there is the VT. Alright, now, so it's what? It's 132 over what? Over total resistance. So it's VT over RT because it's IT. So all of it is just TTT. And then total, that was 11. So what is IT? Then you get the answer. That becomes that. So it's what? 132 over 11. Then 12. 12 amps. Remember, dealing with current. So this question was what? 2.2. So this was 2.1, and then this one is 2.2. All right, then let's look at the last one. Current passing through R2, R4, and R5. This is now 10 marks. R2, R4, and R5. It means it forces us to go back to that one. But anyway, let's start here. Look at this. First thing is, this is the diagram that will give you the current. But now you'll remember the formula. When you're finding current, it says voltage over resistance. So if I come here, I know all my resistances. The other one is 40, the other one is 20, the other one is 40. But there is something interesting here. If I can put my voltage here to say, what is the voltage on this one? It's parallel, right? And what is the voltage here? Not like that. Let me draw it like this. What's the voltage across the 20? And what's the voltage across the 40? Now, guess what? Voltage across the 40 ohms, actually across R3, V3 is equal to voltage across the 4, which is equal to voltage across the 5. Now, why? Because these are parallel. Parallel resistors have the same voltage. So, which means if I can find the voltage here, I'll be done. But guess what? Again, I come here on the second one. I do the same thing on the second one. I say to myself here, if I can find the voltage here and find the voltage here, these two are the same. So voltage 1 is equal to voltage 2. Are you with me? So, but I think I got the voltage. They said what? Look at the other question here. There was a question which wanted voltage. Am I right? Let's look at the question here. They say calculate what? They say the total resistance, the total current, or they wanted the current. So if they wanted the current, I have the current, but I can now look at this. Very interesting when it comes to this. I can come here and say, what is the voltage there? So it will be for V1. And I come here and I say, what is the voltage there? I'll call it V2. If I can find these voltages, I'm done. But don't forget, the voltage here is the same voltage for, like voltage in 1 is the same voltage for 2 and 1. Voltage. V2 is V1, V3, V4, V5. So I'll come here and say, okay, I know the current that is going through IT. So what is current here? The current is 12 watt. It's 12 amps. So here current is 12 amps. 12 amps. So I can then use this formula. V is IR. So how do I use it? I come here and say I is V over R. So if I say here I is equal to V over R, I'll call it I1, which is equal to I1 is equal to voltage. Actually, that's the wrong one. I'm not supposed to find I. What am I doing? I'm looking for voltage actually. Sorry. I'm looking for voltage. Sorry. I'm looking, there is the formula. V is IR. So I want V1 here. This is what I'm looking at. V1. So what do I find V1? Because I have I. So V1 is equal to I dot R. But I know the R, I know the I, which is the I is 12 times the R is 1. So I get that V1. What is it? It's 12 volts. I continue. What about V2? See now how it's going. V2 is equal to, now I'm here. Again, I dot R. Now I know the current is still 12 ohms times R is 10. So V2 is equal to what? V2 is equal to 120 ohms. Do you see this? Very, very interesting stuff. Now, when I've got it like this, if you look at this, let me show you this. If I add these two, V1 and V2, what is V1? 12 plus V2, 120. What do I get? I get 132, the total voltage. You see that now? Because there is no voltage losses here. They don't incur internal resistances and all that. So that is that. That's why you add these two. They give you the total voltage. Why? Because as we said, when the current is the same, if you see 12 amps passing through two resistors, the voltages are different. So what is the voltage here? It's 12 amps. And here it's 12 volts. Sorry, 12 volts. Here is 120 volts. Alright, then the answer then is easier now. They want us to say here, I'm going to have to come back and erase everything here because it will be easier now looking at this. I can then be able to find what? The currents, because they want the current here. They want the current here. I'll call that, they want the current here. We'll call that I2. They want the current here. We'll call it I, not that what, but I'm going to find them. This is I3. This is I4. This is I5. I'm going to just find all of them solo. But guess what? I know the voltage here. What is the voltage here? We just found it is 12 volts here. And the other one is 120. So here it's 12. Even here, I know the voltage here. It's 12. See how easy. Even here, I know the voltage here. 120. Even on this one, 120. Even on this one, 120. You see how it's like. Then from there I can find all the current. Remember, the question is, let's go back again. Let's not lose the question. What was the question? The question is the current passing through R2, R4, and R5. So the current, it's easy now. Remember the formula? I said you come back to this part of the table to say VIR. Then you come and say my I current 1 is V1 over R1. So which is equal to the current 1, V1 over R1. Let's just do this. What is V1? 12, because that's the R1. 12 and R1 is what? Is 2. So it's 12 over 2, which is equal to what? I1 is equal to 6 amps. Right? What about I2? It's also 2 ohms. It's the same answer. Then you can actually say, instead of using that I2, the same formula will be 12 over 2. You can say I2 is equal to I1. Therefore, I2 is 6 amps again. Same resistors, so which means the current was dividing fairly into 2 equal parts. Okay? Then we come here. we are saying what? I is equal to, the formula is what? V over R. So let's go to I3. Let's do it on top. Let's just, so that we can save space. Put it there. I3 is equal to V3 over R3, which is called what? What is V3? The voltage there is 120, it's not changing. The only thing that is changing is that. Are you seeing that? So what is I3? Is equal to what? You come back there and say 120 over 4. 120 over 40, sorry, is 3. So I3 is 3 amps, and then I4 is equal to same thing, is V4 over R4. What is V4? The voltage does not change, 120. What about R4 now? Is the only one that is changing, is that. So what is I4? I4 is 20, that it will be 6. So this is 6 amps. What about I5? Now I5, look at this. I5 is 40 and 40. If 40 and 40 is the same, so I5 will be equal to I3, which is equal to 3 amps. You can literally state that, or you can use the same calculation there to still give the answer. It will be 120 over 4. All right. So then you can answer the question that they wanted. They said what? Find I think it was I2, I3, and I4. So I2, we did I2. Where is I2? There. These are your answers. There is I2, I3, we did them here, and I4, we did them there. Let me look at the question actually. Find the current through R2, R4, and R5. So that's why I'm saying current through R2 is I2, R4 is I4, R5, I5. Guys, that's that. I don't know if ever it makes sense to you, but I hope this is of benefit to you. If you have any questions again on this one after these lessons, well, just feel free. Tell me, did you understand? Tandega, you're the first one. Give me a feedback, because I was doing this with you in mind also. Of course, everyone is important, but I gave this because you asked that question. But how did this fare? We've come to the end of our lesson. Remember to subscribe and ensure the notification bell is turned on. Thank you.